This video is about section 4.4, counting. First, I'll introduce the multiplication counting rule. The multiplication counting rule talks about if we have a sequence of events. Let's say we have the first event, second event, third event, a sequence, and so on. The first event will occur in one ways, and the second event will occur in two ways, the third event will occur in three ways, and so on. Then the total number of outcomes for this sequence of events will be n1 times n2 times n3 times the number of the ways of the rest of the events. Let's look at one example. A fast food restaurant has a meal special. $8, you can get a drink, a sandwich, a side item, and dessert. And for drinks, you have these choices, right? We can say 1, 2, 3, 4, 5. So 5 choices for drinks. And for a sandwich, we have 1, 2, 3, 4 choices. And for sides, you have 1, 2, 3 sides. So 3 choices for the sides. And for dessert, you have either chocolate chip cookie or apple pie. So 2 choices. And we want to know what is the total number of combos. Right, so to get a combo, you have 4 events. To get a drink, and a sandwich, and a side, and a dessert. Right, the number of drink is 5. The number of sandwich is 4. We have 3 sides and 2 dessert. You multiply them together, you will have 5 times 4 times 3 times 2, which is 20 times 6, 120. So in total, there are 120 ways of ordering the combo. The next concept I want to introduce is factorial. For example, 4 factorial, right? Or 4 exclamation mark. This means it's 4 times 3 times 2 times 1. Which is 12 times 2, 24. Similarly, if I ask you what is 5 factorial, that would be 5 times 4 times 3 times 2 times 1. Similarly, if it is 10 factorial, it will be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You get the idea. So when do we use factorial? Let's look at the factorial rule. It says if we have n items and we want to arrange them in different orders. Okay, notice that these n items must be different. You can't have like 2 items that are the same. You have n different items and you want to arrange them in different orders. The number of ways to arrange those n different items is n factorial. For example, say you have 5 balls of different colors and you want to put them in 5 slots and you want to know how many different ways are there. For the first slot, you can pick any of those 5 balls. So there are 5 ways. After you place the ball at the first slot, you only have, for the second ball, you only have 4 ways because there are only 4 balls left. So similarly, after you place the second ball for the third ball, you only have 3 choices. Right? So after you put the third ball for the fourth ball, you only have 2 choices because there are only 2 balls left. And after you place 4 balls for the fifth ball, there's only 1 ball left, so only one way. So according to what we talked about earlier, the multiplication counting rule, the total number of outcomes would be 5 times 4 times 3 times 2 times 1, which happen to be 5 factorial. That's why we say if you want to arrange n different items, there are n factorial ways. Next, we'll talk about permutation. This is a situation when we use permutation. Say we have still 5 balls, 5 different balls. But you only have 2 slots. First slot, second slot. The reason I write first and second because for permutation, the order matters. We want to know the number of ways to fill the 2 slots with those 5 balls. So we will pick 2 balls from the 5 balls. So for the first slot, there will be 5 choices. So 5 ways for the first slot. So after the first slot is filled, for the second slot, you only have 4 choices. So by the multiplication counting rule, the total number of filling those 2 slots with 5 balls will be 5 times 4, which is 20 ways. To see it in the perspective of permutation, it would be choosing 2 balls from 5 balls. Right? So 5 goes here and 2 goes here. This is equal to 5 times 4 because there are only 2 balls, right? 2 here, so which is 20. Another permutation calculation. So what is the permutation of choosing 3 items out of 10? So that will be starting from 10. 10 times 9 times 8. So there are 1, 2, 3 numbers multiplying. This is the permutation of choosing 3 out of 10. You can find this is 90 times 8, 720. So another example, what is the permutation of choosing 8 items out of 20 items? It will be, right, starting from 20, 20 times 19 times 18 times 17 times 16 times 15. How many do I have? 1, 2, 3, 4, 5, 6. Right, I need 8. So times 14, that's 7 times 13. 8. Right, 8 numbers multiplying. So this number is the permutation of choosing 8 out of 20. To sum up, when do we use permutation? When you want to find the number of ways of choosing R items out of N items, and order matters. So if you want to satisfy those conditions, and you use permutation. Usually we want to compare permutation to combination. Similar to permutation, a combination is to find the total number of ways to choose R items out of N items. So the only difference here is the order does not matter when you find a combination. For example, again, we have 5 balls of different colors, and we want to pick 2 of them and put it in a bag. So in this case, the order does not matter. The total number of ways is the combination of choosing 2 out of 5. We write it in this way. And this is equal to 5 times 4. If you just do 5 times 4, that's the permutation of choosing 2 out of 5, right? That's when the order matters. But if you count order, count the orders, you are overcounting a lot of same cases. So you have to divide by 2 times 1. So in this case, it's 20 divided by 2, which is 10. Let's see another calculation of combination. Say I want to choose 4 out of 9, and the order does not matter, so it's a combination. This is equal to, first on top is the permutation, 9 times 8 times 7 times 6, right? It's 4 of them, divided by, basically it's the 4 factorial, 4 times 3 times 2 times 1, whatever that is. Go through the calculations, 126. Another example. Find the combination of choosing 8 out of 11, for example. So on top, it will be the permutation of choosing 8 out of 11. Divided by, the bottom will be the factorial of 8. So you will have 11 times 9 times 8 times 7 times 6 times 5. How many do I have? 1, 2, 3, 4, 5, 6. 2 more. Times 4 times 3. So on top is permutation of choosing 8 out of 11. Divided by 8 factorial, so 8 times 7 times 6 times 5 times 4 times 2 times 1.